Welcome to Spring LIB.
In each part of this problem, we are given the molten form of a compound, and we want to determine what reaction will occur in the cathode and the anode when we electrolyze this solution. In part A, we have NiBr2. So that means that we have Ni2 plus and Br minus ions in aqueous solution. And so we can look up on the standard reduction potentials table list of those half reactions where Ni2 plus is being reduced and where Br minus is being reduced. But we know that Br minus can only be oxidized to produce Br2. So really the half reaction for the reduction is Br2 being reduced to Br minus. But since we are starting with Br minus as part of that aqueous compound in part A, we have to reverse that half reaction from the table so that it now becomes an oxidation reaction. And we can see from the standard reduction potentials, after we flip the sign of the standard reduction potential for Br2, then we see that it corresponds to a negative value of 1.09, which is less than the standard reduction potential for the reduction of Ni2 plus. And so since the standard reduction potential of Ni2 plus is greater than that for the oxidation of Br minus, then we can say that the first half reaction has a greater potential to be reduced, and therefore the second reaction has a smaller potential to be reduced and a greater potential to be oxidized. So that's how we know that the first reaction is the reduction that occurs, and the second half reaction is the oxidation that occurs. And again, we know that reduction occurs in the cathode and that oxidation occurs in the anode. So that means that this top half reaction corresponding to the reduction of Ni2 plus ions will occur in the cathode, while the oxidation of Br minus ions will occur in the anode. The compound that we are electrolyzing in part B is AlF3. So we have Al3 plus ions and F minus ions. We look up the half reactions from the standard reduction potentials table, and we see that we have Al3 plus, which is what we start with, being reduced. We have F minus being oxidized after we reverse a reaction of F2 being reduced. So therefore, similar to part A, the top reaction will be the one undergoing a reduction and therefore occur in the cathode when we electrolyze this compound. And that must mean that the bottom reaction occurs in the anode because oxidation is occurring. And finally, in part C, we have MnI2. So we have Mn2 plus and I minus ions. So from the standard reduction potentials list of the half reactions in that table, we can find these two half reactions that correspond to Mn2 plus being reduced and I minus being oxidized, where we had to again flip the reaction of I2 being reduced. And so again, the first reaction is undergoing reduction and will therefore occur in the cathode, while the second reaction will again occur in the anode and undergo oxidation.